into the plasma. Plasma, of course, is going to be the liquid portion of the blood. What gets left over after blood clots and solids are removed is termed the serum. Basically, it doesn't have any clotting factors. And it's identical to plasma, but there's no fibrinogen. Do you guys remember fibrinogen?
No.
What does it make you think about?
Fibers.
Fibers. And what are the three fibers in the body? Elastic, collagen, and reticular. And even though we don't see those fibers in the blood per se, we're going to have the ability to help give rise to them, okay? Because one of the things that has to happen, if there's a breach in this system, okay, we have to make sure that it clots correctly. Okay, so one of the things it's going to have to do is have fibers. So these would be some of the this would come along with some of the other clotting factors. Under the part of the plasma that deals with the proteins, in the proteins we're going to have albumins, globulins, fibrinogen. So in this protein portion of the plasma, albumins, these are the ones that are going to be the smallest, they're highest in number, contribute to viscosity and osmolarity. What is viscosity?
The thickness.
Resistance of the
How
fluid to flow.
the thickness, the resistance to flow. How about osmolarity? The ability to affect diffusion and osmosis. Okay? Now, those factors, okay, viscosity and osmolarity, are going to play a part on blood pressure, blood flow, and fluid balance. Because albumins, if they're smaller, if they're higher in number, one of the things that they're good for, that they're going to help us a lot with, is to help regulate movement of water between the tissues and the blood. Okay? That becomes very important. So therefore, you're going to read that those albumins are good for something called colloid osmotic pressure, COP. Do you happen to remember what a colloid is? Oh, a keloid.
It's like a mixture, but like
It's thicker.
yeah.
Okay, it's a mixture where stuff gets to keep its own properties. Do you remember that? How we can have stuff either dissolve, or we can have stuff that'll keep its own components, keep its own structures in that liquid.
I remember you mentioned the jelly when you said that. Is that you said something about like food, like the jelly and what do you call it?
The colloid, well, the reason that I'm mentioning it, blood, this plasma, okay, blood is a colloid. Because we're going to have parts in it that keep their own structure that are not going to dissolve. Okay? And because of that, it helps with a pressure that can exist between those blood vessels and the tissues that they serve. And that becomes important for movement of materials. So colloid osmotic pressure is important. Now, another thing that albumins can do, they can bind and transport molecules also. So they can serve as a transport. Globulins help with immune system functions. There are alpha, beta, and gamma globulins. So what are they going to do? They are going to transport, for example, antibodies. Just a small portion of the immune system. Fibrinogen, this is the protein that is the precursor to fibrin threads that will help to form blood clots. So anytime we have a breach in a blood vessel, this is going to be present to help form the clot for healing. The proteins that we find in the plasma, they get formed by the liver. Globulins, however, they're going to come from something called plasma cells. Put that away in the back of your mind for future use. Okay? That those globulins are from something called plasma cells. The fibrinogen and the albumins are from the liver. In those nitrogenous compounds, the waste products, okay, this could be free amino acids from dietary protein that we took in, or if any tissues were broken down, it could be the nitrogenous waste, urea. We could see that this could be from the toxic products of catabolism. For the most part, nitrogenous waste hopefully will get removed by the kidneys. Hopefully, nitrogenous compounds as a whole will get removed by the kidneys. Now, bilirubin is another nitrogenous waste, another waste that we come about with these activities that occur in the cell. One of the things that gets produced when we have to break down red blood cells, one of these waste that's given off is bilirubin. The hope is, of course, that the liver takes care of it, we excrete it, and we're good. All right? However, bilirubin can build up and we become jaundiced. Ever heard of that? Okay. Another product that's going to be a nitrogenous waste, the red blood cells themselves, they spit out their nucleus because they want to have as much room as possible to carry oxygen. Okay? And so the only way that a red blood cell makes energy is by the process of anaerobic respiration. And anaerobic respiration gives off that really huge molecule, lactic acid, okay? And therefore, it's going to have, we're going to find a lot of lactic acid that we need to get rid of, believe it or not, just from the function of the red blood cells. The nutrients that we're going to find, glucose, vitamins, fats, cholesterol, phospholipids, minerals, okay? Stuff that's needed throughout cells of the entire body. Oxygen, CO2, inert nitrogen is going to be found. Our electrolytes, look what makes up 90% of them. We can't get away from sodium to save our lives, can we? Okay? Viscosity. Viscosity. This is going to rule the flow of blood through the vessels? How easily does the blood flow in the vessels? Viscosity is due to cohesion of particles. Cohesion. What's that? What?
Stick together.
How we stick together. Because if we cohese, we stick together. If we adhere, we stick to something else, right? So cohesion is talking about the stickiness of these parts of the blood. Now, water. Flow freely. If I were to turn this on, does it take a long time for the water to start? No. It's pretty easy flow. What if this were to move, I don't know, tomato juice?
Might take a while.
Might take a while to get the start going, right? Whole blood, 4 to 5 times more viscous than water. Now, plasma, twice as viscous. Important in circulatory function. Why?
So it flows everywhere?
Because we got to make sure that there's flow throughout the vessels. Why?
So our whole body can get nutrients, like our tissues. So
Why?
like our heart.
For regulation of temperature.
Okay, we've got to get stuff there. We've got to get rid of the waste. We've got to make sure that we maintain temperature. Okay.
You have an infection to get there to fight it fast?
Feed the cells.
Life.
For life.
To have enough time.
What's the question again?
Why?
Maintain homeostasis?
Viscosity. Resistance to flow. Blood, tad bit of a viscous portion, okay, tad bit of a sticky substance. Have you ever cut yourself and didn't know it right away, and then it kind of got sticky, okay, and you kind of were like, oh, hey, where'd that come from? If the water component of blood is dependent upon your hydration stature, okay? If you are more hydrated, is your blood flowing more easily or harder?
Easily.
It's more easy, okay? If you're dehydrated, that blood's going to flow slowly.